Hello students. Now we will learn about authentication protocols in this lecture. Before two participants are likely to establish a secure channel between themselves, that is by using any kind of encryption algorithm that they exchange among themselves, they will generally wish to establish that the other participant with whom they are communicating to know that who is he or she that is claiming. That means we have to know his or her identity, that to whom we are communicating. That this problem is known as authentication problem. For example, a document came to me without any name or signature. In that case, I cannot identify who sent this, actually, who is the original sender of this message. For that purpose, we require some authentication protocol. So, in this lecture, we will learn about different types of authentication protocols. The authentication protocols are capable of simply authenticating the connecting party or authenticating the connecting party as well as authenticating itself to the connecting party. The authentication protocols are based on two major approaches. One is timestamp, another is nonce. Nonce, nonce. The purpose of the timestamp is to generate a distributed clock synchronization and it has a certain margin of error. Whereas with the uses of none, we can track the past nuns that has to be kept. These drawbacks can be overcome through the challenge response protocol. So let's talk about what is challenge response protocol. Challenge and response protocol is an authentication protocol where Alice sent Bob a timestamp, challenging Bob to encrypt it in response or digitally sign it in a response message. Say, for example, I send an email or a message to you people, and there will be a timestamp that ma'am has sent or I have sent you this message at 10 o'clock. Just for example, and I ask you, when you send it back, please mention my time as well as mention the timestamp of your side as well in your response. Similarly, the same thing is happening here. The challenge for the Bob is to encrypt it the timestamp sent by Alice in his response message. The encrypted timestamp is like an authenticator. That means to whom I have sent the message, that same party is sending me. This timestamp also serves a dual purpose. One is for making the authentication, second is it will check the freshness or the timeliness of the message it has been receiving. Suppose if I send a 10 o'clock message and you send me back your own timestamp with 10 past 2 minutes, then in that case I can check that this message is corresponding to the message which I have sent at 10 o'clock. This is how the timeliness of the message is checked here. Now we will talk about the authentication protocol for public key, and there are two approaches. One with clock synchronization, that means we have a common clock or master clock for synchronization. Second is we can do it without a clock synchronization. Let's begin with authentication for public key with clock synchronization. First of all, the first step in this is that the sender Alice has to send a message to Bob with a timestamp T1 and also have to send her identity along with the digital signature. The very own purpose of the digital signature is to provide authentication because it belongs to Alice. Similarly, on the other end, Bob authenticates this message and verify the freshness of this message through the timestamp T1. Then, in response back, Bob sends a message with another timestamp T2 and his own identity, and as well, it will generate a new session key that has to be encrypted by Alice public key. So, and this all complete message, including the timestamp T1 or encrypted T2, identity of the Bob, digital signature of the Bob, and the new session key all has to be digitally signed, and this message will be floated to Alice. Now, the Alice will verify the authenticity. That means the party is the same one which I have communicated by using its own timestamp. Freshness can be checked by the timestamp 2 as well as it will get a new session key that is from an authenticate party or the receiver Bob. This is how the public key authentication protocol using a master clock can be done. Because we have used the same clock, so timestamp T1 and T2 are following the same system clock. Now we will do the same thing but without a clock synchronization. Now what's to do with the without clock synchronization? There is a slight difference between these two approaches. First, Alice sends Bob a message with a timestamp likewise in the previous approach along with its own identity and authentication of digital signature. Bob sends back a digitally signed message with T1 and his new timestamp T2 because the systems are not common, so that's why it has to affix a new timestamp T2, not to the continuation with the timestamp sent by the Alice. Now Alice has to compare time 1 stamp T1 with original timestamp for freshness check. That means how long it is taking to come back. If it is not coming back within the given timestamp or the calculated RTT, then it will not be the original timestamp or the authenticate. It is not coming from authenticate party. Then Alice sends a T2 and a new session key encrypting using Bob's public key. Now in return, Bob can verify the freshness of message to trust new session key because there is a timestamp T2. Note for this process is that here the timestamp serves the purpose of nonce as well. That is the randomness of the timestamp is there. Now this is all about for symmetric, asymmetric. Now we will talk about symmetric key authentication protocol, and in this there is a one known protocol is Needham-Schroeder protocol, and this protocol can be referred to one of the two communication protocol that is intended for use over a insecure network, and it is named over the this protocol is named after its inventor or the proposed person, those who have proposed it, that is Roger Needham and Michael Schroeder, for symmetric as well as asymmetric. We have already covered the symmetric asymmetric part. Here we will discuss the public key protocol. Here, first of all, what we have to understand what all the entities we have: Alice, a sender, receiver, a Bob, and there is a S entity, that is a server that has to be trusted by both the Alice and the Bob. There is a KAS key, symmetric key, known only to Alice and the server, that is the third party server. There is another session key, that is KBS, and it's a symmetric key again, but known to Bob and server only. There are nuns as well that has been generated by A and B respectively, NA and NB. Finally, the server has to generate a key, session key, KAB, through which the Alice and Bob has to do the whole communication. The process begins like Alice sends a message to the server identifying herself, and Bob telling the server that she wants to communicate with the Bob. Then in response, the server generates KAB and sends back to Alice a copy encrypted under a session key KBS for Alice to forward to Bob, and also a copy for Alice. Since Alice may be requesting keys for several different people, the nuns assures Alice that the message is fresh and that the service is replying to the particular message, and the inclusion of Bob's name tells Alice who she is to share this key with. Now, Alice forwards the key to the Bob who can use it to decrypt the key he shares with the server, the authentication data. Then Bob sends Alice a nonce encrypted under KAB to show that he has the key. Later on, Alice performs a simple operation on the nonce and re-encrypts it and sends it back, verifying that she is still alive and that she can hold that key. This is the whole process of Needham-Schroeder public key protocol. Now, talking about a very important topic in the authentication protocol, that is Kerbros. You might have heard this term earlier as well. Now we will go into the depth of it, how it works. Kerbros is a computer network authentication protocol which works on the basis of tickets to allow nodes communicating over a non-secure network. Kerbros authentication was developed in MIT, Massachusetts Institute of Technology, and that is primarily aimed at client-server model. It provides mutual authentication both to the user and the server, and they are verifying each other's identity using this. Kerbros protocol's messages are protection against eavesdropping and replay attacks. That means nobody can sniff it in middle of the transmission and cannot replay those messages. Kerberos built a symmetric key cryptography and phases of authentication. For this purpose, Kerberos builds a symmetric key cryptography and requires a trusted third party. And optionally, it may use public key cryptography during certain phases of authentication. The Kerbros use port number 88 by default. There are two main components in Kerbros. First, a ticket which is used for the user authentication and securing the data, and an authenticator that is used to verify that the user is the same user to whom the ticket was initially granted. Now, let's talk about that we want to get a ticket for an event. There is a person that want to go to a show or any event. We have a ticket in our hand, and For what purpose we are holding that ticket? Just to authenticate that we are the person, or we are just to allow us to enter into the event. Second is the person who use the user is the same user. That means on the ticket there might be some initials or sign or stamp that will authenticate that this ticket is a valid ticket or not a duplicate or not a fraud type of ticket. So this is the two things that has to be understood in the term of ticket and authenticator. And third important point regarding Kerbros is that the whole operation is based on the working of three servers. First server is the authentication server, another is a ticket granting server, and the third one is a real server. Here is an image where you can see the processes that are going on. There is a red line arrows, there is yellow line arrows, and there are green line arrows, and there is three servers as well we require. Client, there is a client, you can see there is a client, and here, and there is a authentication server, and there is a service server that is known as a real server. When a user logs into a system, the system connects to the Kerbros server, where it retrieves a session key to be used between the user and the ticket granting service TGS. This is an encrypted with a key based on the user password. If the user provides the right password, the end system is able to decrypt the session key. After this, the user password is erased from the memory from avoiding it from stolen or compromised. Now, the tic- ticket granting expires after a set amount of time. When a user wants to connect to a service to which he does not already have a ticket, the user connects to the ticket grant server and gets a ticket that can only be used to access a particular service only. The user can now connect through an encrypted channel to the server. As soon as the ticket is valid, it is okay. But as soon as the ticket gets expired, the user must request for a new one from the ticket grant server. The major issue with the Kerberos is its scalability. The Kerbros server must store secret keys for each of the users and each of the ticket granting server. The drawbacks and the limitations of this Kerbros is it is a single point of failure. That means at one point if the ticket end or the authentication end fails, the whole system gets failed. Kerbros has a strict time requirement that I have talked about, that it will keep on expiring and reissuing of those tickets and all this process. As well as in practice it uses the network time protocol, which will keep the host clocks synchronized with each other. The administration protocol is again not standardized and differs between server implementation. We are talking about server, real service servers. So each server had its own protocol to be followed, and there is mismanagement regarding that. Since all the authentications are controlled by a centralized key distribution center, the compromise on the authentication infrastructure will allow an attacker to impersonate any user. Also, each network surface, which requires a different host name, will need its own set of Kerberos key. This complicates the virtual hostings and clusters.